Today we're going to be covering networking fundamentals. I've divided this video into three main sections: how data travels, common protocols and ports, as well as addressing subnets and traffic filtering. We'll start with the OSI model. I want you to think of this acronym when you think of the OSI model. Please do not throw sausage pizza away. Sounds kind of funny, but why do we try and remember this type of acronym? Well, the OSI model is actually split up into 7 layers. First being the physical layer, second being the data link, then network, transport, session, presentation, and application. Please do not throw sausage pizza away. The OSI model is split into 2 layers, the media layer and the host layer. So the media layers are the hardware components and the host layers are the operating system components. So for the application layer, I want you to think of it as what creates the data. For example, if you use Google Chrome, you click enter, Chrome generates a standard HTTP request asking for the server for its homepage, right? The presentation layer encrypts that data. The session layer separates the data. In this example, it ensures that your request doesn't get mixed up with other open browser tabs. The transport layer chops it into segments and will choose either TCP or UDP, which we'll cover later in this video. Then once it gets to the networking section, it wraps these segments into packets that we discussed earlier. The data link layer is in charge of wrapping these packets into frames. Finally, the physical layer converts it into bits. So the top of the OSI model is the user, and the bottom is the physical components such as the wires, switches, routers, etc. So data is the raw unformatted payload, e.g. HTML code of a web page or a text of an email. Segments are chopped up data with headers containing port numbers. Packets are segments wrapped with source and destination IP addresses. Frames are packets wrapped with source and destination MAC addresses. Frames converted into binary are bits translated into physical signals such as currents in copper wire, radio waves in Wi-Fi. Now moving on to TCP versus UDP delivery methods. This operates at layer 4, the transport layer. Pretty much TCP stands for Transmission Control Protocol and is a reliable and guaranteed delivery. And the features is that it is connection orientated using a 3-way handshake. We'll discuss in a second. So I want you to think of the analogy is that it's a registered mail service where you must sign for the package. And the use cases are web browsing, downloading files, and emails. We also have UDP, User Datagram Protocol, fast and unreliable, best effort. Features, connectionless, sends data without checking if the receiver is ready or if it is arrived. No retransmission. Analogy, just throwing a newspaper at a porch from a moving car. Use cases, video streaming, live gaming, DNS, etc. So for 3-way handshake, I like to use this example. Alice is the client and we have Bob, which is the server. Alice, hey Bob, can you hear me? Over. That's the SYN, which stands for synchronize. Bob, hey Alice, I can hear you loud and clear. Can you hear me? Over. SYN ACK. ACK stands for acknowledge. Alice, yes, I can hear you too. Here is the message. She's acknowledged that synchronize acknowledge from Bob and then sends the data over. Moving on to common protocols and ports. The concepts of ports. So IP addresses gets you to the computer, but a port number gets you the specific software such service on that computer. Think of it like this. Our IP address is the apartment building and the port number is the specific room number. So here are some core web protocols: the HTTP port 80, Hypertext Transfer Protocol, plain text unencrypted web traffic. We have HTTPS port 443, HTTP secure encrypted via SSL TLS, which I'll explain in a second. We also have core infrastructure protocols. DNS, domain name system. The phone book of the internet translates human readable names such as google.com into computer readable IP addresses. Note, mostly uses UDP. Core management file protocols, SSH. Port 22 of secure shell, used to securely log into and manage remote servers via command line. and FTP, File Transfer Protocol, ports 20 and 21 used for transferring files between a client and a server, unencrypted. Quickly moving on to SSL and TLS. SSL stands for Secure Socket Layer. TLS stands for Transport Layer Security, a cryptographic protocol that secures internet communication by encrypting data sent between the user's browser and the server. It ensures privacy by scrambling data, authenticity by verifying the website's integrity by preventing data tampering. SSL is older, TLS is modern. We no longer use SSL. TLS is used to secure the internet today. Finally, addressing subnets and traffic filtering. IP addressing basics. IPv4 structure made of 4 octets separated by dots, e.g. 192.168.1.1, total of 32 bits, public versus private IPs. Private IPs are used inside your home/office network. Public IPs are unique across the entire World Wide Web. Subnetting. What is a subnet? A logical subdivision of an IP network. It groups devices together to limit traffic congestion and improve security. So, for example, the subnet mask tells the computer which part of the IP address belongs to the network ID, the street name, and which part belongs to the host ID, the house number. As we can see in this little example, the blue part is the street and the house is in red, based on the subnet. The final octet being 0. If this last 255 was also a 0, then this number 1 would also be part of the house address. Finally, moving on to how routers and firewalls filter traffic. The router is the traffic controller between networks. It looks at the destination layer 3 IP address of a packet and uses a routing table to forward it to the next destination. Layer 3 is the network layer. Switches occur at the layer 2. Firewall, the security guard standing next to the router. It filters traffic using an ACL, access control list, based on rules you create. Here's a simple diagram. We have a laptop connected to a firewall, which is connected to a router. We have the servers as well with the firewall in the middle. We have a switch also connected to another PC. Thank you for watching this video. Good luck on your interview and stay tuned for more videos.